Welcome back to our 12th video in Lesson 2, which was a review of graphing. We've been leading up to the idea that we can solve algebraic equations graphically by graphing the functions on the left and right-hand side of an equation. Before we actually see all 5 steps in practice, let's take a look at solving an algebraic equation algebraically so that we have something to compare our graphical solution to. We recall that to find the solution of an algebraic equation using an algebraic technique, we isolate the variable using inverse operation. Remember the extra bit of information? The type of inverse we apply depends on the type of equation we solve. We have 6 different types of equation. Each are going to have its own inverse. Algebraic techniques, each equation type uses a different type of inverse. Let's take a look at a problem that asks us to solve an equation algebraically. Here we read the problem entirely out loud and super slow. Use an algebraic technique to solve the equation 3 times 2 minus x equals -8 plus 1/2 x. Every single time after we've read the entire problem slowly to ourselves, I'm going to encourage that we ask ourselves one question. In the math statement, is there an equal sign? In this case, we see the equal sign. Thus, we're going to solve the equation. I would immediately ask, what type of equation is this? We don't see a square on either side, so it's not quadratic. We don't see absolute value bars, not absolute value. There's no ratio with a variable and denominator, can't be rational. There's no radical symbol, it's not a radical equation. And we also don't see x to a power of 3, 4, 5, 6, so it's not power equation. It must be linear. Once we know that it's a solution to a linear equation and we're going to use an algebraic technique, we can go to work. Remember, the first thing that I encourage you all to do once you're actually working towards the solution is to write the entire equation down in your own handwriting. You are the best mathematician in your life. I'm going to say that 50 times. You can do math. You're hella good at math. Write math in your own handwriting. Here I've written the original equation down I want to solve. The first thing I'm going to notice is there's a multiplication outside of a subtraction. I can pass that through. This we said was 6 minus 3 times x minus 8 plus 1/2 x. Next thing we're going to try to do is to get the variable by itself. We notice there is a -3x and a positive 1/2 x. Question, should we bring the positive over or the negative? I tend to try to annihilate negatives in my life because I feel like they make things more complicated. So I'm going to go ahead and write plus 3x. The opposite of subtraction is addition. The inverse operation of subtraction is addition. If I add 3x on that side, I must add 3x on the other side. And I want to make a quick note. When I take 1/2 x plus 3x, we know that in this situation, 0.5 plus 3 is 3.5. Another way to say that is 3 can also be written as 6 over 2x. When we're adding fractions, we need a common denominator. Here I got 1x plus 6x in the numerator and 2 in the denominator. And in fact, these are equalities, not implications, because these are each expressions. Sorry about that. Remember, a chain of expressions are connected with equal signs. 1 plus 6 is 7x divided by 2. 7 divided by 2 is indeed 3.5x. It doesn't really matter which of those you use. We'll use this one for now. So now I've got 6 plus 0. Remember that when we add 0 to anything, we don't do work. We usually don't write that. And then over here, I've got minus 8 plus 3.5x. Let's bring the minus 8 over to the other side. The inverse of subtraction is addition. To get rid of that negative, I do a positive. We see now that 6 plus 8 is 14. Over on the other side, we've got 3.5x. Here, this is a multiplication. I want to get the x by itself. The inverse operation of multiplication is division. In order to get rid of that multiplication, I divide. If I divide on the right-hand side, I must also divide on the left-hand side. And in this case, we see 3.5 divided by 3.5 is 1. 14 divided by 3.5, well, I know that off the top of my head that is 4, but perhaps I didn't know that. If you're at the table screen and you want to get back to the regular screen, you see the little quit button? That's written in blue, so I hit the second functionality. There's that little arrow up in the corner, which means I can get to the blue writing. And then I just wanted to check real quick, 14 divided by 3.5 is indeed 4, what I was trying to say. Claim we've got x equal 4 as a solution. I haven't checked my work yet, so I'm not going to box it, but I can go ahead and check. Remember, when we check, we take the original equation. Everywhere we see an x, we drop in the value that we're trying to check for. Minus 4. We're not sure if this is true, but we want to check. So now I've got 1/2 times 4. This is an equation, so I'm going to write an equivalent equation down there. 2 minus 4 is indeed -2. Here I've got -8 plus 1/2 times 4, which is 2. 3 times -2 is -6. -8 plus 2 is -6. -6 equals -6. Indeed, this is a solution to our equation. We have just used an algebraic method to solve this equation. This was algebraic because we used the opposite of subtraction was addition. That's an inverse operation. We used the opposite of multiplication was division. That's an inverse operation. In other words, we got the variable by itself using inverse operation. That's algebraic. In the next video, we'll see how to do this in a different way that avoids having to work with fractions. I have really, really interesting feelings when it comes to fractions. You'll see that in the next video.